Hi, my name is Hunter Paris, and I am doing this Polkadot hackathon. And it's put on by the wonderful people at encode.club. And there are some prizes associated, but probably the hackathon will be over by the time you see this. So this is the second one I'm doing, although it's the first one on my channel, because I recorded the first one and the audio messed up. So I think my microphone failed. So now we are doing a second one, and although it's the first one you're seeing. So we just pick one of these and we do it. So let's see, there's build a POE, decentralized application. I don't know what POE stands for. What's point of entry, maybe? POE. Is my keyboard working? No, my keyboard is not working. Oh boy. Wait. Let's try. Oh wait, I have a few ones to try. It's this there we go. It's this USB hub thing that I'm doing. So let's get situated. Okay, so POE blockchain. Yeah, there's no proof of existence. I guess proof of existence. That's so we could basically build a decentralized app. That sounds sort of cool. But before we do, I just want to see what else there is. Start a private network with Substrate. Interesting. Forkless upgrade a chain. Build a permissioned network. Node authorization palette. Add a contracts palette to the runtime. And then do smart contracts. Visualize node metrics. Frontier workshop, and then Cumulus workshop. So I've already done this. I've done this. So let's go ahead and build the decentralized application. So try now. Oh yeah, could have read it instead of wasting time Googling. But at least we debugged the keyboard issue, which is probably the most important thing we've done so far. Proof of existence dApp using Substrate and the frame library to take about an hour. We're using Rust. Ooh, React.js, but you don't need to need these in order to be able to complete the guide. We only expect general familiarity, and that I'm open to learning about bleeding edge. I could tell you this stuff is bleeding edge. It's always changing. If you run into an issue, we're here to help. You can ask a question on Stack or a Substrate technical channel, which seems to be on this matrix.to thing, which I've never been on. So we're going to launch it. We're going to modify. Prepare to build. About proof of existence. Proof of existence, an online service that verifies the existence of computer files as of a specific time via timestamped transactions. Okay? Rather than uploading the entire file to the blockchain to prove its existence, users submit a hash of the file known as a digest or checksum. These hashes are powerful because huge files can be uniquely represented by a small hash value, which is efficient indeed. Like a SHA-1 sum or a MD5. I wonder what algorithm they use. Any user with the original file can prove this, or SHA-256, this file matches one of the blockchain by simply recomputing the hash. To add this, blockchains also provide a robust identity system, accounts that map to public keys on top of the identity palette. So when a file digest is stored on the blockchain, we can also record which account uploaded the digest. This allows the controller of that kind of labor prove they were the original person to claim the file. And it all works because of hashing, which, like, the probability of two files being the same hash are typically in these kind of hashing systems like 1 in like to the order of 256. Like, it's pretty much like almost impossible. Install node template. I do. Yeah, so yeah, I already have the node template. Install the front end template, already have that. Interface and design. Our proof of existence API will expose two callable functions: create claim, revoke claim. Claim the existence of a file by uploading a file digest. Revoke claim allows the current owner of claim to revoke their ownership. In order to implement this, we only need to store information about the proofs and who made them. Sounds simple? Let's get coding. Building cut. Ooh, oh my goodness! Look at all these fantastic graphics. And I could hear that there was some movement. There we go. Oh, there's still some movement as it touches my zipper. See? Anyway, it's... Oh, it's because I'm wearing a hoodie. Wow. Isn't that special? Building custom palette. The Substrate Developer Hub Node template, which is used as a starting point, has a frame-based runtime. Frame is a library code that allows you to build a substrate runtime by composing a module called palettes, and you can think of these palettes as individual pieces of logic. Yeah. Here's a frame palettes. Whole bunch of ones with nice fragment with a pH. Colors. Grandpa. Atomic swap. Runtime. Runtime. Frame includes a balances palette that controls the underlying currency of your blockchain by managing balances of all accounts in the system. A contracts palette designed to add smart contract functionality to the blockchain. Palettes for on-chain government. It's like a little digital country in your computer. The goal of this tutorial is to teach you how to make your own frame palette to include Substrate Developer blockchain file structure. Open the node template in your favorite code editor. Then open a file, palette template source lib. So we're going to modify this. We're going to remove contents. Uh-oh. We're going to optionally modify. We're going to optionally modify. You'll need to see some pre-written code that acts as a template for a new palette. When writing your own palettes. When writing your own palettes in the future, you will likely find the scaffolding to be useful. But for the purpose of really learning how a palette is constructed, delete all the contents of this file. So palette template lib source, delete it. Palettes, template, source. Wait, let's palette template source lib.rs. Really? I'm scared, but okay. Oop, not all that. All this. Okay. Deleted. So have a look at the skeleton of a frame palette from the knowledge base to learn more about the basic structure. Oh, I am curious. What's the minimum amount of code? Frame v2. So, oh, not too bad. Okay, I believe it. Events, so let's see. Palette, right? It looks like include kind of code. By the way, I don't know all that much about Rust, which is this language, or Substrate or blockchain. I've owned some blockchain coins, and that's about it. I've been at Substrate and Polkadot for like 3 days now, and that's it. So I'm learning just alongside you guys. Runtime configuration traits. All types and constants go here. Oh yeah, configs. A runtime storage. Okay. Runtime events, hooks, and extrinsics. Cool. General structure. And look at me doing my homework. So, palette scaffolding. Let's just copy it. Yeah. And paste it. By doing this, we've declared dependencies and macros that our palette will require to function. Things like events, storage, callable functions may look similar. We will show what each of these components look like for basic proof of existence palette provided by you with code blocks that go under each section. Critical. All stop. Read the yellow text. Critical. The no standard feature is required for all palettes. This is because we were building a runtime module that must compile to WASM. I know that stands for WebAssembly Language, and therefore cannot depend on Rust's STD dependencies. So if you take a look at palettes, you will see the template where it says STD default feature disabled, which is necessary in order to compile runtime WASM. Learn more about why this is necessary in the add palette. You can use the standard only specifics, and I don't really care. Too long, didn't read. All I know is that the no standard feature is required, and there it is. So, seems fine. But mental note, if something like that stops me or errors for me in the future, I'll come back and really understand what that's about. Palette configuration trait. Every palette is a component called config that is used for configuration. This component is a Rust trait. Traits are similar to interfaces in language like C. So for those of you who know nothing about programming at all, an interface typically mean that is has a relationship. Like in object-oriented program, there's a has a, but from what I've gathered, Rust is not object-oriented, right? Is Rust object-oriented? Is Rust a functional language? Not really an object-oriented language. Although it has some object-oriented characteristics, Rust is not a functional language. Okay, so it's some kind of hybrid language. But typing languages, languages tend to be quite messy, always. Because they need to do a lot of things. Anyway. Oh. I was looking at the palette thinking it was the tutorial. So, and here I was trying to show off. So yeah, interface typically means is a has a relationship as opposed to an object, which is an is a relationship. Right? Like a child is a child of a parent, right? Whether it's an object or human. And then like a child has a strand of hair, although this grown-up child doesn't really have too much hair strands on the head. So yeah, is a has a. The config interface is another topic that will be covered in greater depth in the add a palette tutorial. To define the palette's config trait, replace this thingy block line with this block. So copy, and now let's look for that thing. Okay, so we were looking for palette config. Step 2, code block will replace this. And then Shift F. Oh, where's my syntax? Oh no, syntax. Come on. Where's my syntax formatting? Come on. Format document. What the heck is going on? It recognizes it's a Rust file. Yeah. Why isn't my... I see. So maybe because there's an error down here. All right. Yeah, so there we go. Just want to prove to myself that I'm not insane. Right, so try to format, nothing's happening. Right, there's that error. Do that. Okay, boom. So yeah, that's why it wasn't formatting. Okay. So we did that. Let's read the little nice comments. They've been so nice to add. Because this palette emits events, it depends on its runtime. Okay, yeah. So all this cool looking stuff with brackets. I don't even know what the brackets are. I just want to get on with the tutorial. And I'll figure those things out when I need to figure them out, which is not right now. Pallet events. Now that we've configured our pallet to emit events, let's go ahead and define those events. Our pallet will only emit an event in 2 circumstances. When a new proof is added to the blockchain. Interesting. Yeah, I like high-level concepts. When a proof is removed. The events can contain some additional data. In this case, each event will also be displayed the count and the proof data such as vec-u8. Now, I was reading that Rust didn't have to deal with such low level stuff. So I am sort of curious, like, what the heck is a U8? All right. Rust language. Learn Rust. Read the book. I guess yeah, data types. Data types. Yeah. Okay. Well, I guess you have to declare the all these different integer types, which is low level, and to be honest, I don't like that such low level programming, to be very honest. It really bothers me. But that's what happens when you're on the bleeding edge. And hopefully one day they can abstract away from this. Anyway, as a vec-u8 that is being stored or removed, note that convention is to include an array with descriptive names for these parameters at the end of event documentation. To implement this, replace pallet event with all of this. Oh, I could have used copy. Here, pallet event, all of that. And formatted source feels so good. Pallets use events to inform users when important changes are made. Event documentation is there. Pallet event. Then we got a metadata thing. Account, generate, deposit. Okay, so event emitted when a proof has been claimed. Who claim? Event emitted when a claim is revoked. Okay. Now include the sp-std library. Notice. Oh yeah, there's a vec-u8. Notice here we're using the vec-u8 type, which is normally included in the standard Rust library. We cannot use standard. So instead we use that thing. I guess it's SP standard lowercase vec, uppercase vec. In our mod palette, the SPD standard crate includes many common things we desire from STD, but are no STD. This, I can hear it. It's probably causing bad audio. And because there is no... Maybe it's the design of this thing. No, I removed the sweatshirt, and it has improved that greatly, but for the next recording, I am not going to use this thing. That is for sure. I'm going to implement a normal mic. Anyway. In our mod palette, the SP-STD crate includes many common things that we desire from STD, but are no STD compatible. To use this, though, we must update our palette's dependencies. So it just sounds like some kind of weird library stuff for performance reasons that I don't really care about, but seems to be necessary. So, copy. And this is in a different, it's palette template cargo 2ml. Palette template cargo 2ml. And then SP-STD. So SP-STD. Nope. It's under just the general dependency things, which I don't think. exists because, yeah, the way that this file has been doing it is different. So yes, we will snip. We will snip. See, it's for some reason it's using this other syntax, which is dependencies.sp-std, and then listing each of the things like on a new line. See, just like this, I just copied the syntax from that. Hopefully that's good. Pallet errors. The events we defined previously indicate when calls to the pallet have completed successfully. Similarly, errors indicate when a call has failed and why it has failed. The first of those errors can occur when attempting to claim a new proof. Of course, a user cannot claim a proof that has already been claimed. The latter cannot occur when attempting to revoke a proof. To implement this, replace pallet error line with some nice error thingies. So I think we're defining, first of all, save that. I think we're defining some errors here. We are defining, and syntax format, we are defining an enum, which is like a struct. Basically, an enum is and I know this from other programming languages, it's a list of things. And so here our enum is named error. I don't know what this T syntax means, but I guess it's a type. And the proof has already been claimed. So yeah, no such proof, no proof owner. So these are 3 errors that we are preparing our API to be able to call. So pallet storage. To add a new proof to the blockchain, we simply store the proof in our pallets storage. To store that value, we'll create a hash map from the proof to the owner of that proof and the block number the proof was made. We'll be using frame storage map to create track of this. To implement this, replace pallet storage. Okay, so let's go find pallet storage, which is right here. Boom. And that is way longer than 80 lines. Plus that storage map thing is looking real sketchy. First of all, there's an underscore as an argument. Then there's a Blake2128 concat, which I have no idea what it is. But I'm sure we'll learn about that. So, pallet callable functions is as implied. So what was this pallet storage? It's new proof. Create a hash map from the proof to the owner proof. And the block number, okay. Pallet callable functions as implied by our pallets events. We have 2 dispatchable functions. These functions will be based on using the storage map based on the following topic. If a proof has an owner and a block number, then we know it has been claimed. Otherwise, the proof is available to be claimed and written to storage. Implement this, replace. Okay, so here's a big chunk. Oh, big chunk of code. So this is pallet call. This is that thing that was choking before. And syntax formatting. Beautiful. This is way too small for me and probably too small for you. Minimize that. Dispatchable functions allow users to interact with the pallet and invoke state changes. These functions materialize. These functions materialize as extrinsics, which are often compared to transactions. Dispatchable functions must be annotated with a wait and must return a dispatch result. Okay, so there's the dispatch result with post info. Create a claim. There you go. Wait is 1_1,000. Check that extrinsic was signed. Sure, signed origin. Verify the specified proof has not already been claimed. Get the block number from the frame system. Store the proof. Oh, so this is interesting stuff. emit an event that the claim was created. Oh, there's a 10,000 wait. Revoke claim. Ensure signed. Ensure that it contains a key. And look, there's our error. No such proof. Oh yeah, proof already claimed. So this is sort of interesting now, now that I'm looking for errors. Verify the specified proof has not already been claimed. So ensure proofs contains key and proof that's some kind of reference thing. And then if not, throw the error proof already claimed. Ensure contains key. Error, no such proof. By the way, I also hate references. I thought I was done with that when I left C++, and nope, back to it. Verify the sender of the current call is the claim owner. And and then this OK thing. That's a nice function. OK. Cool. So we sort of reviewed the code. Let's see what the tutorial has us do. So after all that, right? So cargo build release. Get to the terminal. And that was from the previous tutorial. I think this is the right directory. Boom. Cool. An error. Unresolved import pallet. Let's see what that's all about. Right. Pallet hooks is unresolved. Well, I did notice the syntax thingy put this on a new line. This is interesting. So I doubt it's the new line, but let's just see if that does anything. I think we've gotten further. I'm feeling optimistic. But you don't want to like get overly optimistic. I'm preparing myself for failure. I have no expectations at this point. But we have gotten a bit further. So while that's working, let's do our syntax format. Yeah, the syntax format. Weird. Oh yeah, I remember these compiles take like 10 minutes, so I will edit this. Okay, so the compile just finished. And let's see what to do next. Yes, I like to play Go. We have to target, launch it. So, boom, boom. Yay! The node is happening. Again, I'm not sure if this is the what network this is. If this is Polkadot chain specification development. I assume because it just said development that this is probably not the main Polkadot network. And yeah, the -- dev, launch your chain in dev mode, right? So now the front end. I've already done that. Yeah, I've already done that. I'll just do yarn start for the front end, and this takes about 20-30 seconds. This is my custom blend of oolong, Assam, and I think there's one other tea in this blend. No, this is just an oolong and Assam. And while we're waiting for the front end to start. Oh, yeah. Oh, I closed the window, didn't I? No. There it is. So that's running just like they say. Now, we are going to add a custom React component. In the front end template, edit template module.js. So we'll open up a new Visual Studio window. And we'll open the front end template. So I guess since I'm doing this a lot, we'll put sub there and then front end template. Okay, so yeah. So I'm going to edit source template module.js. Source. Boom. I said boom. And then sometimes the brain clicks, but the finger does not press the mouse hard enough. Just checking out what we're about to delete. Okay, so it's a bunch of Node stuff. I mean, React stuff. Actually, have done a little bit of React work. Okay, so some forms. Anyway, copy as you command. Oh, great tutorial. And we replace it with a new form. We won't walk you step by step through the creation of components. Well, then I'm not even going to take your suggestion to do it. I just want to get right to the fun stuff. It should reload once I save the changes. Boom. Aha. What are we looking for? Okay, first of all, let's get this tab into the same tab there. Oh. New component. Oh, a proof of existence component. Oh, there it is, yeah. Tiny little thing at the bottom. Where you choose a file, create a claim, revoke a claim. Okay, so let's go choose a file. And we're going to choose, I could choose the, where is it? The 44 megabyte WAV file. But I want to be nice. So we'll choose this base.midi file. It's only 168 bytes. So we get a file digest. And it's nice and long. Feels longer than SHA-1. Anyway. If we press create, a transaction will be dispatched to, and we'll get an event. Did I don't even remember if I pressed create claim. Yeah, file digest unclaimed. Yeah, current transaction status ready. And yeah, stuff happened. So it was claimed. If all went well, I should see a new claim created event in the events component. I'm pretty sure I did. Scanning, claim created, boom. And our 4AC, and then yeah, our 4AC. So, yeah, front-end automatically recognizes your file now claimed and even gives you the option to revoke if you want. Remember, only the owner can revoke the claim. If you select another user at the top, you will see the revoke. Let's try that. Let's go to, so there's the revoke claim button. Let's go to, Alice Stash. Let's go to Bob, and let's go back to Alice. Ah, cool. Very cool. That's the cool thing about React. It has a very, well, it's very reactive. It has a very reactive state. And other frameworks like Angular and Vue. Remember, only the owner can. This is the end of our journey. Cool. So what did we actually do here? Chose to omit some specific details around development. Yep, very short and satisfying. So basically, we developed a brand new pallet. We launched a custom blockchain using Substate and Frame. Furthermore, I guess the custom blockchain means the development blockchain that we launched. Furthermore, we've shown you that the Substrate ecosystem, that you can create responsive front-end experiences so users can interact with your blockchain. Yeah, makes sense. I guess let's take a look at the code. What I'm sort of curious is how the digest is actually created. Here it is, buffer to digest. Oh, that's where that weird thing is. Blake 256. That's where that weird thing was. That's where this weird Blake 2 thing. I'd wonder what the heck was that. Although it says 128, but I'm sure they've thought of it. Interesting. Okay. Oh yeah, there it is. Blake 2 as hex. Interesting. So we do the hash client side. And then we upload the hash to our chain, I suppose. Interesting. Yeah, so if owner does not equal that, that's right, that's how that is done. Although technically, I do wonder if you could send a message, because this is only happening client side. Maybe some security person can answer that, or somebody who knows more about it. So, cool. So that was that tutorial. Let's go back. That was the build a proof of existence decentralized application. So now on another video, we're going to do another one. So thank you so much for tuning in. This was the Polkadot Substrate Hackathon. And check the link below for links to some relevant content. Like this tutorial page. I'll link the tutorial page, and maybe I'll link the hackathon page. So happy blockchaining.